Definition. A function of two variables is a rule that assigns a real number f, x, y to each pair of real numbers x, y in the domain of the function.
The domain. The domain is the set of input or argument values for which the function is defined. So, the function provides values for each member of the domain.
How to find the domain of a function?
In this video, we want to talk about the domain of a function in two variables. For example, if we have this function, to find the domain, we have to put this greater than 0. And then we found the value of epsilon. Now we draw the graphic of the function. We have a straight line. Now we choose the point to 1 and we replace it in the function. If the equality is true, we will say that the function exists in this part of the graphic. Level curves. Level curves, or contour lines, are another way to represent a function z equal f of x, y. By letting z equal some constant k, we obtain a single level curve. If we do this for several values of k, we have a set of level curves to represent a function. If we want to draw the level curves of this function, we have to create a system between our function and the function z equal k. Now we replace k in the first function. And we will find this equation. This is beam circumferences with center 0, 0 and radius root of k. We have to assign some values to k. For example, 1, 4, 9, and 16. Now we draw the graphic of the function. We can see that the level curves are growing and the point 0, 0 is the minimum point. If we want
maximum and minimum relative points, we can say that x0, y0 is a maximum relative point of the function f of xy if f of xy is less equal f of x0, y0, and we can say that x0, y0 is the minimum relative point of the function f of xy if f of xy is greater equal f of x0, y0.
There are two different methods. The first, graphic with level curves, and the second, algebraic. In this video, we show how to find minimum and maximum points of a function in two variables. If we have this function, we have to find derivatives of x and y. Now we put derivatives in a system to find the value of x and y. We have 2 points, 0, 0, and 3, 9 divided by 2. Now we have to create the Hessian of the first point. We put the second derivatives of x and y. And we solve the Hessian. We can see that the point 0, 0 is a saddle point because the result is less than 0. Now we have to create the Hessian of the second point. We put the second derivatives of x and y. And we solve the Hessian. We can see that the point is a minimum point because both the result and the second derivatives of x are greater than 0. In this
Maximum maximum and minimum constraint points. In research of the maximum and minimum points of a function z, when variables have to satisfy some conditions, like constraints of equality or inequality, we have to find maximum and minimum constraint point.
There are three different methods. The first, substitution. In this case, the procedure is the same of the function in one variable. The second, graphic, with level curves, and the third, Lagrange.